Hey, Seth here from BlenderSensei.com. Today we're talking about kind of a niche add-on that comes shipped for free with Blender called MathViz Console. So this add-on is probably going to be more for add-on developers or people looking for some kind of way to display geometrical data on their screen, maybe a math educator, or maybe someone who just wants to know a little more about what's going on under the hood in Blender. So to activate this add-on, you can go to Edit, Preferences, and then click Add-ons. It's right here at the top. Just check that box and you are good to go. So to use this particular add-on, you're really going to need to head over to the scripting workspace, or at the very least, open up a Python console, because it works by directly inputting commands into the Python console. It also has a graphical display in the Scene tab. So close that default tab up there, and here you can see this add-on has added this panel here. I'll drag that up to the top so we can see it easier. So since we're not going to be really using the text editor and just the Python console, I'm going to go ahead and switch this to the 3D viewport so we have a bigger area to show the stuff that we create in the Python console. So this add-on will take three different types of data that you input into the Python console and create graphical representations of them on the screen. Say we wanted to plot a point right where this corner is. Well, we can see that that point is -1 on the x-axis. So we would give our point a name, my point, probably not the best name. Then you would say equal, capital V, vector, and then two parentheses, so we would say -1 for this negative x value, and then y, because it's x, y, z. So y is going this way, that's going to be positive y, as we can see here, because that's negative going this way. So 1, 1, and then this is positive z going up, because that's negative z going down. And as we can see, if we scroll out a little bit, that's 1 point on the axis going up there. So we would say 1, and then close this, hit enter, and there we get a point where we expected it to be. We can see it has the title of my point. And now over here in the other part of the add-on, this MathViz console, we have an actual variable, an item that we can do stuff to. We can hide it if we don't want to see it. We can delete it, etc. So real quickly, the options here, we can hide the name of the point if we just want to see the nice little pink little point. And we can hide bounding boxes. This is for when we assign a variable to a matrix. Well, the problem is no one can exactly be told what I'm just goofing. A matrix is a set of data used to transform another set of data, such as this cube. But actually, if we plotted the matrix of this cube, that wouldn't be the best example, because the matrix is only a limited number of values needed to represent the transformation directions applied to all the vertices in the object. So a better example would be if we created a Suzanne monkey head, and then we said, say, monk matrix, and we don't have to include matrix in the name of the variable. You could call it whatever you want. I'm just typing that so it'll be easier. Equals bpy.context.object.m, and let's press tab to autocomplete and see what our options are here. We could do the matrix basis, matrix local, matrix parent inverse, and matrix world. I understand about what half of that means, but all of these are referring to a set of points which, when plotted out, look like a cube, but it's a small set of data used to manipulate a large set of data, such as all these points in this Suzanne head. So we could do the matrix world, hit enter, and the MathViz console add-on is now drawing this monk's matrix. As you can see, it draws a little special axis in there also. So that's not like an empty or something. That's being custom drawn to the screen, the same as this white box. And notice this isn't a bounding box of this Suzanne head, because her sweet little ears stick out. So once again, this is referring to a small set of data which talk about scale and rotation and the way in which the rest of the points are manipulated. If we change the monkey or rotate or move the monkey, this data is also updated because its source is coming from this live object here. Whereas if we were to move this cube, that point would just stay there because when we created that point, we just entered in static data. We didn't get that data from the cube itself. So we really should have called that monk matrix world so that we would know better what it was. Let's say we rotate this, move it over, and we'll do monk matrix and we'll call it basis. Actually, let's press up on the console so we can more easily get back to where the previous line. And we'll do a matrix basis, see what that looks like. I don't even really know, to be frank. Or maybe I did at one point, but I don't remember. Okay, so that looks exactly the same. Apparently we haven't made enough changes to this object to warrant a different looking thing from that thing. Let's try something else. What about local matrix local? And in all instances, we are getting the same matrix drawn. Okay, so here's a bunch of variables we now have in the console we could get rid of. This will let us hide the bounding box. I guess all bounding boxes being drawn because there's actually several now, even though they're all being drawn in the same place. Let's unhide those and press tab to go into edit mode and G to grab to move these vertex points and see if that changes anything. Nope, sure doesn't. We can also adjust the scale factor of the matrix, the offset by which these values are being generated. We can change always in front is on. It basically means it will appear transparent through everything because we can see it drawn on the top of the screen. However, it appears to do that all the time anyway, because if I uncheck it, this should be in front of that, but it doesn't appear to be. Okay, and then we have cleanup, which will delete everything that we have drawn. So in addition to drawing individual vertex points, we can send a list of points to create lines by doing the same thing we did with the vector here, which, by the way, this vector function is a function of mathutils, which you can see there's always a message that displays about how Blender automatically loads this mathutils module in the console here. And that is why I was able to just flat out write that particular function without having to import anything first. Okay, so we could draw individual points using the grid to kind of help us determine where we want to put them. But we can also do a list to make lines. So we could say my line equals vector, and we'll just enter some random coordinates. How about 1, 2, 3? But instead of just doing 1, we'll make this a list by putting it within a bracket, and I'll just add a little space there so we can see better, and close the bracket. And to add multiple items to a list in Python, of course, you just enter a comma and add another vector. And this will give us 2 points, which will draw a line. Vector 1, 2, 13. Put my other parentheses there, enter. And now we have a line, and it says my line drawn from these 2 static points. So as you'll recall, when I had the add-on draw Suzanne's matrix, that the white box appeared to move with Suzanne when I moved it. That's because the data was being fed dynamically from a source that changes and updates. We could do the same thing, so let's add a cone, for example. We could do my cone lines equal dpy.context.object, which is the object we have selected, which is that cone dot data, which is the data refers to the contents of the object, which is this mesh of this object, and then dot vertices, and we want to get these vertices as a list. So what we'll do is come back here and say for v and bpy context.data.vertices, and we'll do v.co, hit enter. Whoops, sorry, had to clear the screen there. Okay, so the right way to get this as a list would be to first declare a list. So we could say my cone lines equals like this, hit enter, and then for v and bpy.context.object, which is this selected cone object here, .data.vertices, enter, my cone lines append v.co. So the v is the vertex information, and the vertex information holds a lot of different pieces of information. Only one of those is its actual coordinates. So that's the .co there. We press enter, enter again, and here we can see if we move this cube out of the way, our my cone lines drawn here. So this my line here will never move from where it is, because when we created it, we just entered 2 static points. But if we change the data inside of this cone, like say I grab all these and I rotate them and then I go back into object mode, notice that these have now moved and updated. And herein lies the usefulness of this add-on for developers. It's a way of tracking changes and transformations when you are doing complex things to individual pieces of mesh inside of Blender. So that's pretty much it for this video. Pretty niche add-on, but I noticed there wasn't a lot of videos for this add-on on YouTube. So in addition to maybe helping out a budding add-on developer, I thought it may be interesting for people who just wanted to know what the hell is this thing and how does it do stuff. So thanks for watching. Please subscribe, please like this video, and leave me a comment and tell me what you think, and I'll see you next time. So for thoroughness sake, I'm going to read the documentation for this add-on. Definitely don't have to watch this part of the video if you don't want to. Just making it available for anyone who might find this useful. MathViz console. Sometimes when writing Python scripts, you stumble on complicated matrix transformations, ray intersections, rotation conversions, mesh modifications, etc., where it's useful to view lines, points, and matrices in the viewport to better understand the problem. Creating mesh data for this purpose isn't difficult, but is cumbersome. The purpose of this add-on is to make it as quick and easy as possible. Activation. Open Blender and go to Preferences, then the Add-ons tab. Click 3D View, then MathViz Console to enable the script. Instructions. MathViz works by displaying Python console-defined mathutils, typed variables, in the 3D viewport. The following types are supported: point, line, transformation, transformations without translation. Usage. And this is mostly just a big picture. Create a Python console editor. In the Python console, define a mathutils variable. And by create a Python console, they just mean open up a Python console editor. And then there's the example, hello world equals vector, parenthesis, parenthesis, 1, 2, 3, parenthesis, parenthesis. You should now be able to see this point in the 3D viewport. And that's it. Thanks very much for watching, especially if you stuck around to the end of this video. Please subscribe if you're not subscribed, and let me know down in the comments below if you plan on using this add-on, if you think it would be helpful to you at all, if you've got some interesting ideas for use cases, stuff like that. That would be really cool to share with me and everyone else. So thanks very much for watching, and I'll see you next time.